The beach. Beautiful coastline, magical area where ocean and land meet. Processes that go behind it are everything that we look at in Earth science. I hope you enjoy this video looking at different types of beaches, from flat beaches to cliff beaches, and everything goes along with it. Welcome to the Earth Science Classroom, and looking at flat and cliff coastlines, as I said before in a little opening video of the crashing waves. And this is one of my favorite topics, is coastal processes and coastal geomorphology and waves. And I'm a big surfer. I actually grew up bodyboarding all my life in England, surprisingly, living by the coast. And I used to live about 10 minutes away from this beach over here in the top left-hand corner, this lovely version of a cliff coastline, and down here in the bottom we have the example of a flat coastline where there is no cliffs, there is no elevated coastline or rocky sea cliff, just had a nice slow small gradient going from the swash and the backwash and the beach face up to the inland onshore area and the coastline. So this video is going to look at certain things. The main differences between cliff and flat coastlines and how they relate to how we characterize coastlines. We'll look at in more detail the flat coastlines, look at the terms and landforms that are associated with flat coastlines, and then the same for cliff coastlines. At the end, we're going to do a little compare and contrast, what the similarities, differences between these two types of coastline. So, part one. So, in a previous video, the intro to coastal landforms, I discussed how we classify coastlines, and there was different classifications. Now, one of them is primary coasts and secondary coasts. Primary coasts, that is going to be more of tectonic and processes that really are internal. Okay, and then secondary coasts, that is more on the action of waves, wind, currents, obviously tidal changes, but they're more like the external. They're the external factors that can change a coastline, again, over a long period of time. In the last video, I used the word emerged or emergent and submergent. So emergent means to rise up through uplift, and where the sea level is per SL, the sea level is going to drop and expose more land. Whereas submerged, you have the sea level is going to rise and cover more land and submerge more of the coastline. So you can have a primary coast or either coast, primary or secondary, relate to either emergent or submergent, depends on where it is and location. So basically what is causing the coastline to be degraded or built up? Is it through tectonic processes, which is primary, or is it more of the action of hydraulic action, abrasion, attrition, through the wind and water and waves and currents? That would be secondary. And some of these different variations of coastlines I mentioned in a previous video are listed here in the orange: the barrier island, the delta coastlines, volcanic coastlines, and fault coastlines, which are obviously tectonic. Coral reef coastlines, again, similar to barrier island, and obviously fjords and ria, which is more of the submerged. So we can link this. We can link this to this could be mostly cliffs, because you've got submerged valleys and streams creating estuaries, okay, and lagoons, right? Estuary is kind of a lagoon right there with more vegetation, and lagoon is like an area of water that's cut off by the ocean by either a spit or a certain bay. And you got the coral reef, again, is mostly submerged. It can be also flat beaches. You've got volcanic and faults, again, tectonic. The delta and barrier island, again, this is going to be, could either be submerged or uplifted, depends on the location, but generally is going to be submerged and mostly going to be flat. All right, so again, we can bring in other things as well. For example, we can discuss the coastal material. Is it soft or is it hard rock? Which will then relate back to, is it going to be flat or is it going to be cliffed? The physical setting, the latitude, the climate, location, again, would indicate whether it's flat or it's cliffed. Then is there going to be a accumulation, aggregation of material or sediment, which again would link to barrier island or delta or coral reef, or is going to be degradation where it's going to be broken down and taken away from the beach, the sediment and the material. And then you're going to look at the erosional agencies and the biological agencies that are at work on that beach. Can also give an indication whether it's going to be flat or cliffed, and also each type will link back to each of these green list right here, and a cliffed coastline will be different in coastal material than a flat one. Flat coastline would, obviously. All right, so on to number 2 now. So looking at flat coastlines, and as you can see by the diagram, my lovely hand-drawn diagram, looking at a flat coastline, the ocean obviously is in blue, sand, sediment accumulation of material, unconsolidated material, sand, gravel, silt, clay is the yellow, and then you have over here, you have the accumulation of sand beyond the shore, right, in a part of the coastline called the coast. Now, there are definitive areas, as you can see by the top terms of offshore, nearshore, foreshore, backshore, and coast and shore. There are definitive locations within the coastline that these terms apply to. So in here, I'm just going to add this in, we have our lovely sand dunes. Okay, accumulation of sand through mostly wind and some wave action, and it's usually up higher on the beach, away from the high tide mark. Then we have the beach right here, which is the accumulation of unconsolidated material deposited by wave action, usually either sand, gravel, or pebbles, depends on the type of material and the amount of erosion and breaking down of that material. Next is called the berm. So the berm is part of the beach. Actually, no, I'm just going to do it right there. B-E-R-M, the berm. This is the raised area of the beach. So in this diagram on the left, this is the Outer Banks. You've got the berm, which is right here. This part here where the lifeguard seat is located. And it is a raised, elevated gradient profile higher up than the high tide mark, but it is usually involved with storm waves and storm situations. But it is a raised kind of flat plateau before you go down to where the water's edge is. So it's that little raised ridge of accumulated sand up the beach where you see less wave action, but it is involved with storms and high waves on occasion, but generally it's higher raised part of the beach. Right here is the beach face. It is the part where you have the swash and backwash rising up, the ebb and the flow of the water going up and down, going inland and back to seaward. So this is the area where you have, it's part of the intertidal zone, and it's right here on the diagram. Again, it's right here. Here's the beach face right here. It's in between the ocean and the berm. And we're linking up the top terms as well. So the berm is part of the back shore, and the beach face is part of the foreshore. And then these two combined would just equal the shore. All right. And the coastline, there's a line right here, and this would be the coastline, just technically a line that separates the shore from the coast, where you have more of an inland coastal region, and that coastline extends until there is a definitive change in landscape or terrain. So you might hit a different biome or a different geomorphological area. But some coastlines go for 50 to 100 miles of the same landscape as the beach and the shore and the coast. Therefore, the coastline will extend that distance, whereas some might change within 10 feet. But flat coastlines generally have a very long, wide, and extensive coastline. Then we have the near shore, and it extends from around 20-meter depth of water up into basically the shoreline, which is right here. Shoreline is right here, where the water meets the sand. And this is where you get your surf, your breaker. So your breaker zone is located in the near shore, and we get most of the breaking waves and the white water. Now, the breaker zone is another term for surf and waves that have broken, which means they have either, here's a wave, they have turned over. The top part of the wave right here is moving faster than the bottom because there's friction against the seabed, a certain depth called wave base, and it's going to turn over. Now, there are 4 types of waves, but we'll get onto that later on in a different video. Now, the offshore part right here, that extends from the where the breakers start to operate and the surf is active on the beach, all the way off until the edge of the continental shelf. And depends on the location. That could be 10 miles, 50 miles, even as much as 50 miles. Depends on the location. But continental shelf is going to be a slow gradient down under the water to get to the continental slope, where there's a sharp decrease or sharp increase in depth, and the gradient goes down into the abyssal plain or the abyssal or the bottom of the seabed, and the ocean starts to really get deep. Another term for near shore can also be inshore as well, which is again related to the breaker zone and surf. The foreshore would have the swash, which is the water going up the beach, okay, and then the movement through gravity going back to the water is called the backwash. So you have swash, and we have backwash going back. Oh no, backwash. There we are. Some books, some terms may also include what's called the coastal area, which again includes anything from the near shore all the way through the dunes and the start of the actual coast and coastline. Now, in terms of this flat beach profile, it depends on the tidal range, because there's basically 2 to 4 meters or above 4 meters. So it depends on the tidal range, but generally the flat beaches do have a very large range for tidal generally. So you'd have there'll be a point on the beach where there'll be a low tide mark where the water's gone out away from the beach, and there's a point where the water comes up through the tidal movement of the water up, and it's called the high tide mark. So there'll be a difference, let's say here, all the way to here, and this would be called the intertidal range, the range between the low tide, which is away from the beach, and the high tide, which is higher up the beach, but it may not include or be close, or basically will cover the beach face, may not go up to the berm area of the backshore. That would only happen whether it be some storms or a tsunami or a storm surge, something like that. Right, so now on to the number three, the cliffed coastlines. Obviously, there's a clear difference in the coastline area compared to the flat one, flat coastline, but pretty much similar layout in terms of the other part of the diagram. So again, with the offshore section, we've got the near shore section. We have the foreshore, which is part of the shore. All right, and this smaller region right here, which is the back shore. And again, it's very small based on the gradient and because there's a cliff there. So the beach has been been shortened through either erosional processes or lack of deposition, or just the fact that the cliff is right there and it's hydraulic action and abrasion is causing the sediment to be removed. So the beach is a steeper gradient, and therefore there's less beach exposed. So you've got the back shore and you've got the coast there, and this line right here would be the coastline. Obviously, right here we have the cliffs. All right, they're obviously wave cuts, and under weathering and erosional processes, usually hydraulic action, which is the action of water smashing against the rocks. Water can pick up rocks or material and smash it against the cliffs, which would cause the joints and bedding planes to become unstable and broken and chipped off. You can also force air into the rocks, which again would break apart the rocks, or even water in the rocks and then cause freeze thaw if it's in a colder climate. And then you'd look at different kinds of weathering through that, mechanical weathering. And abrasion. Abrasion is it's where you have the rocks material hitting against each other and they get broken, and in most cases they get smoother. So that is where you get all the breaking. You get this the formation of a notch, which is right here. And this notch is basically an undercut of the cliffs where the water actually connects and hits with the cliff. It's going to break down that part of the cliff, usually by the beach, sooner, quicker, more effectively than the higher parts, and that will cause the cliff to look like this. So look at this there normally, and you have the ocean here, say, and the waves. And then what's going to happen is very slowly it's going to break apart this part of the cliff. And then what's going to happen is there'll be an overhang. And because of gravity and because of wave action, that overhang is going to fall down, okay? And then it's going to look like this again, and the water is going to come up and repeat the process, another notch, and eventually that's going to cause the coastline to recede inland and move away from the current coastline and expand the beach. In terms of the back shore and the foreshore, we have the berm right here, this elevated area here, and the beach face right there. We have the high tide mark right there, with the low tide mark there, and also the low tide area where the breaker zone begins, the surf zone. So this area here, again, is the intertidal area, intertidal, and it depends on the tidal range. This area here is called a long shore bar. It's a parallel deposit of sand or material that's in the near shore area. It's like the extent where the breakers or the waves start to break, and it depends on the depth. But you get the wave base kind of hitting the seabed and causing it to slow down and depositing some of the material and sand, causing this elevated sandbar, which goes all the way along there and basically dictates or helps to dictate where the surf is going to happen. And there's also an area right behind it called Longshore Trough, which basically is going to accompany the longshore bar, and basically the water's going to move over the bar and then deposit down here and leave a little area here, the little depression right there with no sediment. And you get the accumulation of sediment here that causes, obviously, the beach to build up, but it can be smaller based on the amount of hydraulic action and erosion taking place at that beach. So the similarities and differences, obviously going through the two different types, flat versus cliffed or cliff coastlines, you've got some obvious differences. You've got the sand dunes and accumulation of sediment, vegetation on the flat coastline versus the striking cliffs of the cliff coastlines, where the cliffs could be anything from a few 20, 30 feet up to hundreds of feet. Depends on the material, depends on how fast they erode, depends on if there's a headland or there's a consistent cliff. But the beaches also can change in the width and the material that is producing the beaches, and the amount of hydraulic action as well. So the cliff can move. Also, the sand dunes can move. So there's movement and there is dynamic processes going on both sides. The beach seabed or topography can also be very similar or very different, whereby the flat coastlines could have a very gentle near shore and foreshore seabed gradient going off to the continental shelf and into the offshore section, compared to a very steep and short gradient for the cliff coastlines, where it's a fast drop down into the deeper parts of the ocean and the continental slope. So these have very similar processes in terms of wave action, tidal currents, tidal ranges, littoral currents, and basically the beach is the same between the berm and the beach face. Intertidal zone as well will be very similar. So that's pretty much it for coastlines. We're going to go into more detail onto the different landforms that are created in different videos, and I hope you guys enjoyed this. If you haven't subscribed or liked, please do so. It's always nice to see, and see you next video. Thanks.